Okay, so today we are going to start center of mass. So even though the topic is center of mass and center of gravity, today we will be covering center of mass. In our next class, we will discuss what is center of gravity. Okay, so write down the topic center of mass. Yeah, sure, we'll do that. So write down the topic center of mass. Okay, center of mass is a fundamental concept in physics that represents the average portion of all the mass in a system or object. It is the point where the total mass of the system can be considered to be concentrated. Okay, so you can highlight this part. The highlight. Oops. Yeah, so write down this under this. It is the point where the total mass of the system can be considered to be concentrated. Yeah. It is the point where the total mass of the system can be considered to be concentrated. Okay. So write down that. It is the point where the total mass of the system can be considered to be concentrated. Okay. Now, for example, if you have a large ball, for example, okay, and if you want to consider the center of mass, so the center of mass is a point, actually a point. So we can think this entire mass, let's say capital M, okay. So this object has mass capital M. So we can consider this entire mass is concentrated at this point. Now, for example, now we studied like a kinematics equation of car, right? For example, the kinematic equation of a car, but the car has a size and all. But did we consider that? No, we consider a point, like how long it will take to reach from this point to that point, right? So there, what we are doing is we are dealing with the center of mass of the car, okay? Or it can be a van. So again, we don't consider or bother about its width, length, or anything, uh, unless in the question if they have asked. Okay, but in kinematics, what we do is how long how long it take for the car or van or for the particular object to move from this point to another point. There we have considered actually the motion of the center of mass, where the total mass of the object is concentrated at a particular point. So that point is known as the center of mass. Okay. Okay. So after writing the topic center of mass, just write down it is the point where the total mass of the system or object can be considered to uh, be concentrated. Okay. Now, for example, here you can see a spanner is being thrown. So uh, now if I throw the spanner in a straight line, okay, so it will actually rotate, right? But its center of mass moves in a straight path. Okay, we will see that shortly. Okay. So the point where the entire mass of a system or object can be considered to act regardless of its actual distribution. Okay. The same definition here what you wrote. It is a point where the total mass of the system can be considered to be concentrated. So the same meaning is here, the point where the entire mass of a system or object can be considered to act regardless of its actual distribution. This concept is crucial in mechanics as it simplifies the analysis of motion by allowing the system to be treated as if all of its mass were concentrated at a single point. Now, for example, let's say here a bat is being thrown. So this person is throwing a bat, okay? Or maybe, yeah, it's look like a bat anyway. So here, if you try to explain the motion of each individual particle, so here if you consider this particular point on the bat, so that is after some time here and then here, then it will be very difficult. Then to explain that now you have to do big maths, right? But if you consider only the center of mass, the center of mass will go in a parabolic path because we know if we throw a ball uh, under the gravity, it will move in a parabolic trajectory or path. Okay, or as you can call the loci, right? Locus. So the locus is a parabolic path. So here, what center of mass is moving in a parabolic path. Okay, right. Okay, and there's another way I can say or define the center of mass. So center of mass of our body is defined as the point at which applied force produces a linear acceleration but no angular acceleration. So the center of mass of body is defined as the point at which applied force produces a linear acceleration but no angular acceleration. So this one I can explain like this. So let's say we have a object, okay, and its center of mass is here. Could be some rock, for example. Okay. So let's say its center of mass is here. Okay. And if we apply a force, let's say F, you apply a force. Okay. So I'm applying this force along the center of mass. Okay. So the center of mass lies on the line of action of this force. So this is the center of mass Cm. Not central minister, it's center of mass Cm. For short, we can mark it as Cm, center of mass. Okay, so here you can see this center of mass is in the line of the applied force F. So then there will be no any rotation motion. This object will move only in this direction. There will be only a translational velocity. Okay, but it won't rotate. Now, if I can see, if I take the same object, if I take the same object, let's say this is its center of mass, Cn, and I'm again applying a force F. Okay, this time I'm not applying this force through the center of mass, but somewhere here. Okay, so when I apply the force somewhere here, okay, then there will be a rotation motion as well. So now this force will be a unbalanced force. Therefore, this will move with the same acceleration. Now this one will gain some acceleration. So let's say that acceleration is in this direction, A. Okay. So A you can find A equals F over M, where m is the mass of this object. So if the mass and applied force is constant, therefore this one also gain the same acceleration, a. Okay, and but the difference is this will also rotate. This will also rotate. Okay, there will be a rotation motion as well. Okay, so I want you to write this part. Okay, so here you can write. So we can write translational motion. Translational motion will be there, but no rotation motion. No rotation motion. Okay, and here we can write both translation and rotation will be there. Okay, quickly write down this.
Excuse me, sir.
Yes.
In the second figure,
Yeah.
will the object travel along a circular path, or I mean, like, will it go like a bend, or will it go straight?
It will go straight. While it's moving straight, it's also rotate.
Okay.
I can show you with the picture. Yeah. Hold on. Okay. Have you finished writing this? Okay, I'll erase. Okay, now let's say there is a hammer, right? So in this hammer, we know the center of mass will be somewhere here. Okay, will be very close to here because this part is made of heavy metal and this is wood. So the center of mass is more like here. Okay, so center of mass is here, CM. Now I am applying a force here, F, an unbalanced force. Now due to this unbalanced force, what will happen? The object will accelerate in this direction, right? So if I apply the force only once, what happens? Due to that force, it will accelerate there will be impulse force, so it will accelerate in very short time, and then with that speed, it will move in the constant velocity, right? Because if I keep applying the force only, it will keep accelerating, right? If I apply the force only once, like for example, I can give a impact force like kick, right? So then it will accelerate in very short time, and then whatever the speed it gain, it will move with that speed, right? Now, since I have applied the force somewhere here, you can see there is a distance between the center of mass and the object. Okay, so there is a distance between the center of mass and the place where we apply the force. So therefore, what will happen? The motion will be look like this. Okay, so while it's move, it rotate. Okay, but overall, the center of mass will not change, because we know if we apply a force in horizontal direction, the object will move in the horizontal direction. There is no vertical motion of the object. The object will move in the horizontal direction. So the center of mass will follow that horizontal direction. Okay. So, okay. Did you all understand? Do you have any questions? So here, each of that center of mass will be at the same. I'm marking the center of masses. So you can see while the object is moving, so there is a translation motion as well as it's rotating. But the center of mass is follows a horizontal motion. Okay. Did you all understand this? Come on, guys, please don't be silent. Say yes or no. Even someone say no, I would appreciate, because I need to understand whether the student understood or not. Otherwise, I won't be satisfied, so it's difficult for me to move forward. Okay. During the corona time, when the pandemic comes, then and the adirini, what you call curfew was there, no? So then all the physical class was stopped, and then I didn't do any online class, because for me at that time, I mean, like, I won't get the satisfaction. Now, if a physical class, I can see whether the student wrote the note or whether they understood. We can interact with the student, right? But when it comes to online, it is much difficult. For that reason, I didn't do any classes for 2 months, and then November and previous month October. For those 2 months, my earning was totally zero. And then one of my friend only, he asked me to do online class for his sister, uh, who was studying at MLC in Sinhala Medium Physics. So for her only, I started like an individual class for a first session. That time I charge only 500, because due to such reason I can't take advantage and all. So then that is the first class, and then after that only, by little and little, I started get used to these online classes. But anyway, still I need to get the satisfaction, like, so please interact with the class. So if I ask you a question, if you didn't, if, for example, if I ask you understood, say yes or no. Okay, even if you say no, I would really appreciate, so then I get idea. Okay, this student, two students didn't understand, so I have to explain again. Okay. Okay, so then here this center of mass will be in the horizontal direction. Okay. Now the next example,
Excuse me, sir.
uh, next one, I take the hammer again, and then this time I'm applying the force to the center of mass. Okay, F. I apply the force through the center of mass. So therefore, in this time, the hammer will move in horizontal direction, with the whatever the velocity it gained within that short period of time. So then, but there won't be any rotation motion. Okay. So the center of mass will be in the horizontal motion. There is no any change. Okay. Okay. So you can quickly note down such. You can draw. No need to perfectly draw a hammer. You can draw something like this. For example, take a object like this. For example, you can draw something like this, and then indicate this is the center of mass. For example, or you can, for example, you can, or else here you can take this point as center of mass and applying the force here. So that is this case one. Okay, and then this will follow something like this. Then you can draw the next one figure like this. First you can take a screenshot because I won't give much time. If in case you couldn't write means, then you can complete that later. So in the next figure you can draw like this. So the main thing is center of mass should not change. It has to be in the same point, the vertical horizontal direction. So if no need to draw a hammer, you can draw something like this. So in the third figure you can draw as moved rotate further. So now you can see this object has, this hammer has translation motion. It position changing and also its rotation. It also have a rotation motion. Okay, so it has a combination of translational motion or linear motion and rotation motion. So we have a combination of linear motion and rotation motion. Okay. By the way, what is the definition of rotation motion? Where all the move particles of the object. If you take object, the definition of rotation motion is every particle move in a circular path and there is no any motion in the center of mass. That is the definition for rotational motion. When it comes to rotation motion, we will study about it. Okay. And then here you can draw like this, and then like this. Okay. So you can draw something like that later. You can take a screenshot of this to get some idea. And if you apply the force through this object through the center of mass cm, so then it won't change. It will keep progressing, moving like this. Okay, the center of mass won't change. Okay, I hope it is clear for you all. If there's anything doubt or any questions, you can ask. Okay. Now, for example, let me now, for example, let's say I take this hammer. So now let's say, for example, I'm applying the force on this. In such direction. So let's say this is the center of mass and I apply a force. In this direction. Then what happens? So I'll draw dotted lines to indicate the path of the center of mass. Okay. Now what happens then? This hammer will Okay, I think I can't do that. Yeah, so if I apply a force in such a way, then what happens? So then here, the hammer will move like this. The center of mass will move through this line. You understand? Okay. Okay. And then we can write. Okay. The mathematical formula. For a system of n particles with masses m1 and m2, let's say there are n number of masses in a system. Okay. Or maybe you can think an object which is made of n number of small particles m1, m2, m3, m4, okay, and so on. Like let's say there are n number of particles there in this object. Then its center of mass is defined by this mathematically. So R, the position of the center of mass. Let's say you are measuring from some reference. RCM is equals to sigma MI RI. That means, now let's say this is the reference point O. Yeah, you should remember this formula. Okay. Sigma, let's say this is the RCM, the vector. Okay, center of mass. So let's say this is the M1 particle. Then its distance is, let's say, R1. And then M2 particle distance R2. Okay. So then, okay, I'll explain completely about this. Okay, so therefore, the center of mass is given by, okay, I'll explain clearly then. Okay, for a system of n particles with masses m1, m2, m1. Now, for example, let's say there are three particles, 1, 2, 3. Okay, and this is m1, and this is m2, and this is m3. Okay, and if you want to find the center of mass of this three body system, then let's say this is the origin reference point. On this point, you measure the distances. Okay, so let's say this distance r1, and this is R2, and this R3. Okay, R1. So R1 is a position vector. So they have bolded is because these are bolded because it's a vector. You know, you may have studied vector notations. So one is you can write something like this vector, or you can write like this, or you can bold. So bolding the letter also one way of representing the vector. Okay, so okay, so here let's say these distances R1, R2, R3. And let's say this is the center of mass of this system, somewhere here. So this is the center of mass, R, capital R, RCM. So the RCM we can find actually m1 times r1 plus m2 times r2 plus m3 times r3. You had to add all the MR products divided by the total mass m1 plus M2 plus M3. Okay, so this is what only written here. So here we have n number of particles, therefore RCM is equals to summation of, you have to add MIRI. So you will study this notation especially in combined max in series. Okay, so here it says at I equals 1 to, so here I equals 1 to n. Now for I 1 to n, and also take the summation of masses I equals 1 to n mi. Okay, so that is what it means. Okay, so now if I want to write this for this system, okay, if I want to write this equation for this system, then I can write RCN is equals to sigma I equals 1 to 3, because there are only 3 particles, M1, M2, M3, MIRI divided by sigma mi. So sigma mi I equals 1 to 3. So you add all the masses M1, M2, M3. Okay. Simply, for example, let's say sigma n I equals 1 to 4. This is equals to, then you have to put, let's say I take here I, okay, sigma I equals 1 to 4. That means, so first you put 1 for I, and then you put 2 for I, plus you put 3 for I, plus 4, from 1 to 4. Okay. So this is the definition for mathematical formula for the center of mass. We will be doing more questions about this. Okay, so you can simply write R is equals to sigma mi ri divided by sigma mi. Okay, so this is, what is this actually? This is the moments. Now you have studied F into the perpendicular distance, no? So they what do we call the moment of force? These are the moment of masses. Okay. So here we have to take the summation of moment of masses divided by the total mass. Okay. So that is the center of mass. It will be very clear when we do some questions and all. When we move forward, you will realize. Now this is for discrete, like we have 1 mass, 2 mass, 3 mass. Now suppose if we have uh, a solid continuous mass, then we have to integrate. Okay, we have to integrate. Now in combine max, you will be doing now center of gravity. Now to find the center of gravity in combine max, you use this equation. You have to integrate uh, this RdM over dm. So we will be doing this in combine max integrations. Okay. So this is the definition. So you can write down this. Okay, this part is not necessary because in physics you don't have to do any questions with uniform, but still again, sorry, you don't do anything finding with continuous calculations, but again you will be studying the center of mass of continuous objects, like for example solid sphere and solid plate, circular disc. We will see that soon. Yeah, you will study those things today. Okay. So let's move on. Okay, now let's say we want to find the center of mass of 2 masses. Okay. Okay, so here we have 2 masses. Okay. Let's say we have 2 masses, M1 and M2. This is M1 and this is M2. Okay, hold on. Okay, you can take a screenshot of this. Give me a second. Okay, now let's say we want to find the center of mass of two objects. Okay, so here we have two masses M1 and M2, and we want to find the center of mass of this mass. Okay. Okay, so here, according to that definition, so what is the definition for center of mass? RCM is equals to sigma mi Ri divided by sigma m. Okay, so in words, how do you write? The center of mass is equals to sum of the moments of the masses divided by total mass of the system, or simply we can write total mass. Okay, so this is in words. I think you should write in words also. Okay, in the previous slide we wrote RCM is equals to sigma mi Ri divided by sigma mi. Okay, so you need to add all the moments divided by total mass. Okay, right. So now let's use this formula. RCM is equals to sigma mi Ri divided by sigma mi. Okay, so here we have two masses m1 and then distance x1. So m1 x1 plus and then m2 x2 divided by m1 plus m2. So therefore this is the center of mass of these two mass system. So if you take this system, so this is the center of mass. Okay. Okay. Right. Now, for example, I will tell you some additional something that is additional. Now, if you take, we know the Earth is rotating around the Sun. Earth is revolving around the Sun, right? So we consider Earth is moving in a circular path, right? But in reality, the Earth is moving in a elliptical path, right? Because if it is moving in elliptical path only, we have seasons, right? When it's go far distance, then we have this winter. When it comes closer to the sun, we have summer. Okay, the winter is mainly because of the seasons are mainly because of this moving in a elliptical path. Okay, but here in our aero syllabus, even the NASA is consider that Earth is moving in a circular path and do calculations like Newton's law of gravity to find how much of energy needed to send a satellite to the orbit and all. Okay, right. So here we come to the core thing. Earth is moving around the sun in a circular path, right? So that means Earth is moving around the sun, but in reality, so this is also out of syllabus. Okay, in reality, actually the sun and earth both are rotating around the center of mass of this, right? So if you take this is the sun, if you take this is sun and this is earth, then both are revolving around their center of mass. But the sun has very large mass. We know sun's mass is, if I'm correct, 6 into 10 to the power 29 or 30 kilograms. But earth is, I think, only uh, around 10 to the power 24. So I think a million times bigger than, sorry, I'm not sure. I think, yeah, some roughly, I think like that. Okay. So since sun's mass is very large, its center of mass of the system will be very close to sun, somewhere here. Then earth is approximately going in a circular path. Okay, this is something additional. Okay, when you, if you go university, then you will study this earth sun movement with considering the center of mass. But in here, in A level, we think sun is stationary and earth is rotating around the sun. Okay, right. Okay, so this is the formula to find the center of mass of two uh, masses. Okay, now here, you can find this mass is big. That means it has small particles, right? So actually, then first what you have to do, first you have to consider the center of mass of this body, which is here. Okay, okay, first you need to consider the center of mass of this one, which is here. And then you have to consider the center of mass of this particle, which is here. So the distance are taken to the center of masses of each masses. And then you take the moment to find the center of mass of the system. Okay, is that clear, guys? If there's any question, please let me know. Okay, so let's move on. Okay, I'll give you an
Excuse me,
example.
sir.
Yes.
So the more massive an object is, the more massive a particle is, the closer the center of gravity it is to
Yeah.
that object.
Yeah, center of mass will be closer to the massive one. Now, if, for example, we will do three more questions related to this, so we can you can understand. Now, for example, if we have two masses, both like this is 2 kilogram and this is also 2 kilogram. Let's say this is 2 kilogram and this is also 2 kilogram. Then the center of mass will be at the midpoint of the line joining their center of masses. So it will be the midpoint here. CM of the system will be at the midpoint. Okay, we'll do some questions. Yeah.
Excuse
So
me,
write down the
sir.
question. Yes.
Is it like a ratio, like the ratio of the masses and the ratio of the distances are equal?
No, actually here we are balancing the movement. Okay.
Ah, okay. Okay.
Okay. So okay, all right. I'll give you some questions. Okay, write down this question. Find the center of mass of each of the following. Find the center of mass of each of the following uh, system of masses. Okay, so the first one, let's take. I have a mass here. Uh, 3 kilogram. Okay. Let's start with the um, equal mass. Okay. So you can take this reference point anywhere. Okay. So let's give this length here. Okay. Let's say the length is the distance between these two masses. The distance between the center of masses of these two is I gave 10 centimeter. And let's say you are taking the movement somewhere away from 1 centimeter this side. Okay. 2 centimeter, for example. Okay. So now I want to find the center of mass of this mass system. The first one I will do as example. Okay. So now let's say I want to find the center of mass. So RCM is equals to m1 times x1 plus m2 times x2 divided by m1 plus m2. So therefore m1 3 kilogram into distance is 2 centimeter plus m2 is 3 kilogram and the distance is uh, 2 plus 10, 12. I'm taking the moment from this axis. So measuring the length from this axis. Okay. Yeah, I consider maybe, for example, x equals 0. Okay, the origin. Okay. And then divided by m1 plus m2. 3 plus 3, 6. So here we get 3 into 2, 6. 3 into 12. 3 into 12 is 36 divided by 6. So then we have 3 into 2 and 3 into 2 plus 10, 12 divided by the total mass 6. So here we have 36 plus 6, 42 divided by 2, which is 40 divided by 6. So we get 7 units centimeter. Keep in mind I have included this in centimeter, so I get in centimeter. That means the center of mass will be 7 centimeter away from my reference point. Okay. So 7 centimeter. Okay. So this is 7 centimeter means, okay, 7 centimeter means here already 2 centimeter is there, then this will be 5 centimeter. So if this is 5 centimeter, then this will be the midpoint. Since the two mass are same, the center of mass will be here. Okay. Okay, quickly write down this and then I'll give you another question. Okay, so this is I consider I'll do this in two methods. Okay, so this is just method 1. So I want to teach you all the methods. Okay. So then method 2, I'll do it here. So in the method 2, I'm going to take my reference point here. Okay. I'll be taking the reference point here, which is in the center of mass of this 3 kilogram. Okay. Now I write the definition. Right? RCM, I mean this center of mass equation, m1 times x1 plus m2 times x2 divided by m1 plus m2. Okay, so RCM is equals to m1 3 kilogram. Now distance is 0. The moment will be 0. Okay, the distance will be 0 plus m2 is 3 into the distance is then 10 and divided by 3 plus 3. So then we have here 3 into 10, 3 into 10 divided by 3 plus 3, 6, which is 3 into 2. So 3 and 3 cancel, we get again 5 centimeter. You write in both the methods, okay? And also there is another method, okay? The third method I will explain. Okay, and I will do the third method. Third method, which is really okay. I will do the third method. Method 3. Okay, so method 3 is uh, it's what similar to what you studied in the moment of force, right? In moment of force, you studied sigma FD is equals to Fi di. Fi di equals to R times D. The sum of the moments about any point, sum of the moment of force about any point is equals to the net torque of the moments is equals to the excuse me guys. Sorry, the third method is similar to what you studied in moment of force. In moment of force, we studied that the net moment, the sum of the moment about a point, okay, is equals to the moment made by the resultant by that by from that same point. Okay, so here, then here what I'm going to do is, now let's say this is the center of mass. Okay, this is the center of mass. I'm taking the moment from that point. Okay, so if I take the moment from that point, let's say I want to find that distance. This distance is x, I don't know, and then therefore this is 10 minus x. This will be 10 minus x. Okay, this distance is x. This distance will be 10 minus x in the unit of centimeters. Okay, so then I'm considering the moment. So the moment of mass of this will be 3 into uh, 3 into x. Okay, so let's say this is making a clockwise movement, then this mass is making a anti-clockwise movement. So it is minus 3 into 10 minus x is equals to the resultant, something like resultant. Therefore, here the resultant will be the total mass actually, m1 plus m2 into, now the distance to, I'm taking the moment from the center of mass, therefore distance will be 0. Okay, so now I have to solve this and find the x. So 3x minus 30 minus and minus plus 3x equals to 0. So 6x equals to 30. So x equals to 30 divided by 6. So x equals 5 centimeter. So therefore this length which should be 5 centimeter, meaning that it will be at the midpoint of the 10 centimeter. Okay. Uh, all three methods. If you understand all three methods, raise your hand. Okay, I'll explain the second method again. So in the second method, I'm taking this point, I mean this center of mass, this point as the reference point, like the origin, right? I measure the distances from there. So then I can find the RCM. This is the formula. Formula won't change. So then mass is 3 into distance. So I'm taking the distance from that point. So then the distance will be 0. So therefore x1 is 0. And then this 3 and the distance is 10 centimeter, 3 into 10. And the total mass m1 plus m2 is 3 plus 3. So then if you solve, here 3 into 0 is 0. And then here plus 30. The 30, so I can write 3 into 10. So here 3 plus 3 is 6, which I can write 3 into 2. So 3 will be cancelled. 10 divided by 2, 5 centimeter. Okay. Okay, I'll explain the third method again. Okay. In the third method, it is similar to what we did in the moment of force. Okay. So here we consider the moment. For example, let's say here the mass, since it looks messier here, I'll redraw here. Okay. So this distance is 10 centimeter. The distance between the center of masses of each mass is 10 centimeter. So now I want to find the center of mass of this. So I don't know where the center of mass is. So this 3 kilogram and this is 3 kilogram. I assume the center of mass is here. I assume the center of mass is here. Let's say that point is CM, center of mass. Okay. Then I mark the distances. I want to find the location of the center of mass, the exact location. So let's say this is X. So if this is X, if this length is X, then this length will be 10 minus X. Okay. Now I'm taking the moment from here, the net moment from here. Okay. So that is, for example, let's say this is, for example, now I'm going to actually, okay, so for example, if you consider this weight, now this weight is 30 Newton, right? So we consider without the weight, let's say the mass is downward 3 kilogram. Actually, it's not the mass. You can do with the weight also. So let's say weight is 30 Newton. Here the weight is 30 Newton. Now this is actually the moment of force, because weight is a moment of force, because from this point, if you consider the weight is making a force, its weight is a force and then perpendicular distance. So that's a moment of force. So then I can consider this side moment, which is 30 into x. Okay, 30 into x. Okay, and then this one is making anti-clockwise movement. It tends to rotate this direction, so it's minus 30 into 10 minus x. Now instead of here masses, I'm writing the weights, so that's why I'm using 30 here. Okay. So then here the weight will be, the total weight will be m1 plus m2. So m1 plus m2 into g, no? The weight is m1 plus m2 into g, g is 10. Into, now I assume this is the center of mass, so therefore the distance will be 0. The moment will be 0 from that point. Because you see it's acting on that point. So the moment for this force, the net weight is 0. Okay. So now here you can see this 10 and here the 10 and here 10 cancel. So you can take the moment of mass. So moment of mass is actually derived from moment of weights. The moment of weights, you need to find the center of gravity. Okay. After the next topic is center of gravity. So this is actually what you do. This is what you do in center of gravity to find the center of gravity of two masses. Okay. Okay. So here, if you cancel the G10 here, then you will get the center of masses and the moment of masses minus 3x 3x minus 3 into 10 minus x equals here 0. Then if you simplify this, you get x equals 5 centimeter. That means the center of mass is 5 centimeter. The value of x is 5 centimeter. From here, it has to be 5 centimeter, which is at the middle. Okay. Okay. Any more questions?
No more kids.
Okay. Quickly write down all three methods. And then I'll give you a question. You have to find its center of mass. Okay. So write down the question. So no need to write the same thing only I had to say. I mean the sentence. So I'll give you the figure. So let's say this is 2 kilogram and this is 4 kilogram, and then distance between them, let's take 10 centimeter. I don't know either one of the method you can use to find the center of mass of this system of masses. Don't take much time. You can use either one of the method and quickly do it and find the center of mass. Suppose if you find that to be here somewhere like 3 centimeter, then how do you write? 3 centimeter from 2 kilogram towards the 4 kilogram. Okay. Because sometimes if they will give a question, two masses 1 kilogram and 5 kilogram are separated by distance of 10 centimeter. Find the location of uh, the center of mass. Then they haven't given any illustration, they haven't given any points to mark. So therefore, if you found the center of mass location, you had to say like this: the center of mass of this system is 3 centimeter away from, 3 centimeter from 2 kilogram towards the 4 kilogram. Understood? Or if you find somewhere here, or maybe you can say, or you can say, or else this is 3 centimeter, you can say 7 centimeter towards 2 kilogram from 4 kilogram. Okay. Now, if I'm doing this question, I think Hirosh got the answer already. 6.67 centimeter from 2 kilogram towards the 4 kilogram. Means here, 6.67 means somewhere like here. Okay. Okay, so who else got the answer? Okay, so here, now I want to find the center of mass. RCM is equals to, I take from this point, I consider this point. So then I will get 4 into 0 plus 2 into 10. 2 into 10 divided by 4 plus 2. So then I get 20 divided by 6, which is 6.6666. We get because 10 divided by 3. Yeah, sorry. 20 divided by 6. Here I get 3.333. So 3.33 centimeter. So that's correct. So Hirosh cut from this side, it is 6.6666, which we can write 6.67 centimeter. So I found that from here to this side as 3.33 centimeter. If you add those two, you get 10. Okay. And the third question, I have 3 masses now. 1, 2, and 3. Distances. Distance from center of mass. Okay, let's say this distance is 8 centimeter. This take 2 kilogram, and say this is also 2 kilogram, and let's say this is this length is 10 centimeter. Take 12 kilogram. Okay, find the center of mass. Okay, I know I didn't teach you how to do this one, but hitanda puluwan vendoni. Now you are in A level, you should be able to think how to find the center of mass. This, if you got a new question, you have to think. අර හිතන්න පුළුවන් වෙන්න එක තමයි හදාගන්න ඕනේ ඒ level එක. I'll give you 3 minutes and then I'll start explaining how to do this. Okay, and I got an answer. Says from 12 kilogram to this direction, 6.67 centimeters. Okay, so who else got the answer? Let's see whether this is correct. Okay, so we will do it like this. Okay, I'll explain. Okay, sure. I'll wait. Okay, I got another answer from 12 kilogram. This side 2.5 centimeter. I think 2.5 centimeter is the correct answer. Yeah. Okay, so here I'll quickly explain how to do this. Now here you can consider these two masses. Okay, and then you can find its center of mass. So because we don't know how to find the center of mass of three body system, but the two body system we know how to find, right? Using this formula, right? So then we can use that to find the center of mass of this. Since the two masses are same, you will get the midpoint. Okay. By the way, I forgot to mention one thing here. This length and this length has to be same. Okay. That is my mistake. I have to mention that. I have to say this length and this length should same 4 centimeter. Okay. Then only it will come to here. Then the center of mass of this will be, this mass will be here. What is the meaning of center of mass? Center of mass is the point where we can think the whole mass is contracted. So then we can think this 2 kilogram and this 2 kilogram is now, instead of being there, that 4 kilogram is now here. Here now its mass is 4 kilogram. Now then we have again two masses, the system of two masses. Okay, one is 4 kilogram here, one is 12 kilogram here. Now for this system, again I can use this this one. So I have I'm using from here, or from, maybe you can take 1 centimeter away and measure. Anyway, you can take either one of the three methods I told you. So I'll take from here. So then here I have 4 kilogram into 0, because distance is 0, because I'm taking from there, and I have 12 kilogram into 10 centimeter, divided by total mass now 4 plus 12, 16 kilogram. So kilogram, kilogram, kilogram cancel. We have 12 into 10 centimeter in the numerator, divided by 16 is 4 into 4. So this 4, this cancel 3, and 10 divided by 4 is 2.5. So 3 into 2.5 centimeter, which is 7.5 centimeter. So that means from here to here it's 7.5 centimeter. So that 2.5 centimeter is correct. Okay. Okay. So here we can see the mass to this ratio between the masses is like 3 to 1. So again, therefore the distance will be here 3 to 1. Here 2.5 into 1, here 2.5 into 3. Did you understand that? The mass ratio is, we can find 3 to 1. Therefore distance will be 3 to 1. Because if you take the moment from the center of mass, if you take the moment from the center of mass, now this is the center of mass, now Cm. So then 12 into, let's say this distance x and this y, 12 into x should be equals to 4 into y. Right? Therefore, the ratio x over, or I take y over x ratio. So y over x ratio is equals to 12 over 4. So which is equals to 3 over 1. So this 3 to 1 ratio should be, okay. If you understood the movement of force field, so these things understanding is very, very easy. I mean, so the movement of force. Now here actually we can consider the movement of weights. Weight are movement of force, because weights are forces. So when in the weight you take mg, so the g when cancels out, then we get moment of masses. Okay. Okay. If you have any questions, you can ask. Okay, I can give you more questions. Okay, I can give you more questions. Like for example, let's say I have a square. Okay, in this square I have masses. So this one 1 kilogram, 2 kilogram, 3 kilogram, 4 kilogram, something like that. Maybe I can give this again 2 kilograms. So you have to find the center of mass of this system. Then how should you should do? First you can take these two because these two same mass, no. So first you can take the center of mass of that. So it will be here in the center. And then you can find the center of mass of these two. Since this mass is large, so the mass ratio is 1 to 3. So the length ratio will be 1 to 3. So the center of mass will be here. Okay. And then after that, what you have to draw, you have to consider the straight line joining these two, and then you can find the center of mass of this. Now here the total mass is, now here it is 2 and 2 4 kilogram, and here again 4 kilogram. Oh, nice. Then therefore it will be at the midpoint of this line. So likewise, I can give you enormous number of questions, but to do those questions, the basics only you have to understand. If you understand the basic, then you can do any type of questions. Now, if I try to give every type of questions, then the time is not enough to do the class. Okay. So with this, I will move on to the next part. If you have any questions, you can ask. Okay. Okay. So the next one we have, okay, moment of mass, sorry, center of mass of a, uh, I'm sorry, I think in the previous one, instead of center of mass, I will be, I'm using moment of mass. Sorry. Uh, okay, I think everything is clear, right? Okay. Okay, now here, let's say we want to find the center of mass of a mass distribution. Like for example, let's say we have, let me draw this. So we have coordinate system xy. So this x coordinate, y coordinate, and then we have masses. Okay. Mm. So here we have masses m1, here m2, and m3, m4, m5, m6, m7, m8, m9, and m10. For example, we have 10 masses. Okay, it can be any number of masses. Okay. Okay. Okay, now we have a mass distribution. Okay, and it each of have different x and y coordinates. So this one, let's say, this one is x1, and then this is y1. Y1. So that one I can mark by the coordinate value x1 comma y1, and then this is x2 comma y2, and here x3 is x3 comma, now y3 is 0, no? The y value is 0. So likewise you can mark all the coordinates points. Okay. Okay, now we want to find the center of mass of this. The center of mass, let's say it's here, for example. Apparently, let's say here. Okay, so this is, I'll mark here. Let's say this is the center of mass, and its coordinate, let's say x bar comma y bar. Now, if you want to find the center of mass, means you want to find this x bar value and y bar value. Okay, to find the x bar, okay, to find x bar value. So x bar means it will be this length, no? This length. Okay, so this one x1, x2. So for that, what you have to do is you want to take the movement, taking the moment of mass or moment of weight. You can think this is in a horizontal plane and all the particles are there, and then these particles weight acting downwards, something like that. Also you can think taking the moment, you can say moment of mass or moment of weight. Even if you take the moment of weight, you will get g, and then g cancels both sides, so again you will get the same thing. So since we are talking about center of mass, we will take the moment of mass. Taking the moment of mass uh, of the system about y-axis. So we want to take the moment of masses about y-axis, right? So then what we get? So here m1 x1 plus m2 x2. So these I'm taking the moments from y-axis. So this one has length x1 and this one has length x2 and so on like that. Okay. So m1 x2 plus m3 x3 plus dot 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 2. Thus we have 10 mass m10 x10. So this is equals to the moment of mass, or we can take uh, the moment by the total mass. So here m1 plus m2 plus m3 plus dot 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 plus m10 times x bar. Okay. So if you consider, I can explain you this with the uh, moment of force. Okay. So each mass weight is, let's say, acting vertically downward. Then you have take the moment of weights. Now I'll explain you here. Then if you take m1g times x1 plus m2g times x2 plus m3g times x3 plus dot 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 plus m10g times x10. So this is equals to the moment of each force is equals to the moment made by the resultant about the same point. So the resultant will be the total mass times. So it's will the total mass of the system is, let's say, m. So m is equals to sigma mi. Okay, that means m1 plus m2 plus I equals 1 to 10. If I want, or else if it's confusing, then I write m equals m1 plus m2 plus m3 plus dot 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 plus m10. So this total mass making the moment about x bar. Okay. So here I'm writing the weight. So here force mg into x bar. So if you can take divide g both sides, then you will get this equation. Okay. Did you all understand this? If there's anything not clear, please don't hesitate to ask. Okay. Okay. So then this one I can compact and write. So this entire thing I can write how? I mean this one I can write like this. So I have sigma mi xi. Okay, sigma mi xi equals to sigma mi times x bar. X bar is the coordinate of the center of mass. If you want, you can use x naught for the center of mass, x naught comma y naught as the coordinate. So it's a matter of symbols for x bar. Okay, it's the coordinates of the center of mass. Okay. So then here we have sigma mi xi equals to the total mass is sigma mi. You add all the masses times x bar. Therefore, x bar is equals to sigma mi xi divided by sigma mi. This is the same, the definition you wrote earlier. Okay. Then to find the y bar, you can get the same expression sigma mi yi. You add all the moments about x-axis, okay, and then divided by the total mass. Okay. Then now you can write the coordinate of the center of mass. Okay. We will do one example. Okay. So first you had write taking the moment of mass of the system about y-axis. Then you can write this, and then I think no need to write this part since we didn't. Okay, that writing that also not wrong because we already studied a moment of forces, right? So weight is a force. Okay, and then after that you can write this one. Okay, and then again you have to say after writing this x bar, then you can say taking the moment of mass of system about x-axis. So then you have to take the moment of mass about the x-axis, then you will get when you take the moment of mass about x-axis, you get m1 times y1 plus m2 times y2 plus dot 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 plus m10 times y10. Okay, so that is equals to total mass times y bar. Okay, so that is what I have written here. So now here if you want you can write I equals 1 to 10, but here I am writing for all general cases. Like for example, if you have any number of mass, then you can simply write sigma mi yi. So for this one, if I'm writing this equation, then x bar is equals to sigma I equals 1 to 10 mi xi divided by sigma mi I equals 1 to 10. Likewise, you can write for y bar also for this particular case. But in most general, then I no need to write I equals 1 to 10. There I have to write I equals 1 to n. N means n number of masses are there. Okay. Okay. If you have any questions, ask me before I clear the screen. Okay, let's do an example. If I try to do again, it will take me time, so I have already think. Okay, so here I have to hide the answers. Okay, hide and wow. Okay, so here we have a mass distribution. We have to find the coordinates of center of mass. Find the center of mass. Here, this is y-axis in the units of centimeter, and this x-axis, the unit of centimeter. And here 1, 2, 3, 4. 1, 2, 3. Now this drawing is not so good because the gaps has to be equal length. Okay, don't do that mistake. These gaps has to be same interval. The length has to be same. I didn't get you. What is the x bar value? You are asking about this question now? Because still we didn't do any problem to find a value. It will be easily understandable if you can unmute and talk. Much appreciated. Okay, I want you to try this question. Okay, let's see who can do this. There are one, yeah, spoiled. Okay, there are three masses. Here 3 kilogram, here 2 kilogram, here 5 kilogram at the distance of 3 centimeter. Here it's 3, and here it's -1. It's -1. Here the coordinate. Okay, I'll write the coordinates here. Coordinates are -3, comma 4, and this one -2, comma 3, and this is my 3, comma -1. So there are three masses, and then you need to find its center of mass. Okay, so you need to find the x bar and y bar values. Uh, you done, share your workings, okay, please. You can draw the figure later. You can take a screenshot, do only the question. Okay, we don't have much time. So take a screenshot and leave a space to draw this diagram, and then do the problem. Later you can draw the diagram. Okay, just quickly get me the answer. Suppose if you got x bar equals, let's say, -1, and y equals, let's say, 0, then the center of mass will be here. Suppose I'm saying, if you got x bar, y bar as those values, then this will be the center of mass. Okay, so by finding this coordinates value, you can find its the center of mass location, position. Three is in. So here this 3 kilogram. This is 3 kilogram. Coordinates are -3, comma 4. This 2 kilogram. Yeah, here 5 kilogram. Coordinates are 3, comma -1. Its value is 3, and this -1. Okay, I got one answer. Mass x equals -1 and y equals 13. So the -1 comma 13 as the coordinate of center of mass, which means x is -1 and plus 13 something. Yeah, it cannot be 13 because all the distance are maximum distance 4 here in this. So it has to be bit less than that. Okay, typing mistake. Then put the correct answer here. Before you finish, Abhyushani, Khalid. X equals 0.2. Y equals 1.3. Okay, let's find this. So here first I'm going to find the x bar coordinate. So x bar is equals to sigma mi xi, okay, divided by sigma mi. So about y-axis you have to take the moments. So starting from this 5 into the distance is x value is 3 plus, and then 2 into -2, 2 into -2 plus 3 into 3 into uh, -3, 3 kilogram into -3. So here you get minus, right? Plus 2 into -2 is -4 because I'm considering the clockwise. This side is plus, then that side will you get minus, right? So that makes sense. And divide by total mass 5, 2, 3, 10. So here we have 5 into 3, 15. 15 minus 4 and -9 minus 13 divided by 10. So 2 divided by 10, 0.2 units of centimeter, because these are in the units of centimeter. So that is x bar. And then for y bar is sigma mi yi divided by sigma mi. We want to take the moment about x-axis. So sigma mi, we have 5 into y value is -1 plus, and then 2 into 3 plus 3 into 4 divided by total mass 10. So -5, and then here 2 into 3 is 6 plus 3 into 4 12 divided by 10. 6 and 12 18, 18 minus 5 13 divided by 10 1.3. So therefore here coordinates 0.2 and 1.3 is correct. So therefore the center of mass is actually 0.2. So here 2 1, so 0.2, and y is 1.3. So here will be the center of mass. This is the G will be here. Coordinate 0.2 comma 1.3. Okay. Okay, so likewise then you can this type of question also I can give in various type. Like I can even add another mass here. Okay, I'd ask a small question. If I add a uh, mass here, okay, let's say 3 kilogram or 1 kilogram mass. If I add 1 kilogram mass here, will the this x value of this will change? Will it change? If I add 1 kilogram on the y-axis, so the x bar value, does it change or not? Will it change or not? I got one answer. Okay, I got two answers. Okay, one said yes, one said no. The answer is yes, it will change because the total mass is changing. The moment won't change, right? But the total mass is changing now in the system. So when you divide by that total mass, then the value will change, okay? Right, because earlier we divide by 10, now we have to divide by 11. So therefore, it will change, okay? But when you are writing in the moment, sigma mi, then 1 kilogram into 0 only that term will come. The moment will be 0, right? Okay. Any questions? I think all good. Okay. So here answers x bar is 0.2, y bar is 1.3. Okay. All right. So here we move. I have done next topic, center of mass of rigid bodies. Okay. Rigid body means shape does not change. Okay. Now, for example, this is a rigid body because I apply a force, but it's not changing. So it's a rigid body. Okay. Okay. But for example, if you take a jelly, jelly, jelly. If you take that, that is not a rigid body, right? Or for example, a piece of rubber band, it's not a rigid body. Okay. So here we are discussing about the center of mass of rigid body. Okay. So yeah, this part is okay. Regardless of an external force or force applied to it, rigid body does not deform or change shape. So no need to write anything much of this, just only the thing you should understand. A rigid body maintain its shape and size even when subject to external forces. Okay. But in reality, no object is perfectly rigid, but many can be approximated as rigid bodies. Okay. Now, if I take this and if I apply a force, there will be a even in micro nanometer range squeeze can be happen. Okay. So perfect rigid bodies are not there. It's actually mathematical, but you won't get asked any question deep like that. Just keep in mind, rigid body is when you apply force, in shape size does not change. Okay. Okay. So under that, we will be discussing about the rigid body, center of mass of uniform objects. Okay. So that means the density is uniform, mass distribution is uniform. Okay, I think we are at the end of our discussion. Okay, center of mass of uniform object. So the density is uniform or the mass distribution is uniform. So these objects have continuous mass distribution, right? So actually to find the mass, center of mass of these bodies, you need to integrate. So it is not there in our syllabus. So that is equal integral of sigma mi dx divided by integral dm. Okay, so that is the integral that we had to do, but it's not there in physics. Anyway, so here we have uniform objects. Now, for example, if you take a sphere, okay, if you take a sphere, uniform sphere, then its center of mass will be at its center point, midpoint, no? Right? And if you take a square metal plate, then its center of mass will be its midpoint. You draw two diagonals and the midpoint. And then center of mass of a rectangle is, it will be in the midpoint. Okay. The cylinder, so it again, the height midpoint in the principal, the center axis, and the for example, height is let's say 10 centimeter, then at the middle point 5 centimeter, that will be there. Okay, so we can write a note. The center of mass of uniform objects the center of mass of uniform objects will be at their geometric centers. If you take a sphere, if you consider its geometry or circle, now if you have a circular disc, in that geometry, the center, the geometric center is the center point, right? So it's the center. Yeah, I'll repeat. The center of mass of uniform, or else we'll write like this: center of mass of an uniform, sorry, of a uniform object is or will be, sorry, come on, okay, hold on. The center of mass of uniform objects will be at their geometric centers. The center of mass of uniform objects will be at their geometric centers. Or else I can say like this: center of mass of uniform objects will coincide with its geometric centers. Okay, it will coincide with its geometric centers. Because now suppose if it's not uniform, let's say you have this sphere, but here larger, this very thickness, like a lot of mass is there, but here thin, then the center of mass will be somewhere here. Okay, right? But if it's uniform, the center of mass will be coincide to its geometric center. Okay, so you can say like that also. Okay, the center of mass of uniform objects will be at their geometric centers. Okay. Now, for example, what is the geometric center of a triangle? We have a triangle. How do we draw the geometric center of it? So for that, what you do, you have to draw a line from one vertex to the midpoint of the other opposite side. So this is the midpoint. And from here, you draw a line to the midpoint of the other side. And then if you draw correctly, then automatically the third one will go from here. So then this is the center. This one you should note that, because other things are easy, square, rectangle and all. But for the triangle, yeah, this length is equal to this length, and this length is equal to this length, and this is equal to this, and this is the center of mass. Draw the triangle, this one draw. Okay. Okay, so from this we are done with the theories of center of mass. But questions because we can give many as possible questions. Okay, infinitely many questions I can give. Okay. Okay, so if you have any questions or doubts regarding today's session, you can ask. In the next class, we will do center of gravity. Center of gravity also very similar to this. So we can finish it in the next class. All right. If you're all okay, then I can wind up the session. Yeah, sure. I'll explain that part. Okay. So that is the last part is two forces with equal magnitudes. Okay, but acting opposite direction. Okay, so you want to find the line of action of it. So now here F, the resultant will be 0. If there is no resultant means no line of action of the resultant. Okay, that's all. Do you understand, Yosh? It's a force couple, right? Two forces acting in opposite direction with equal magnitudes. Then it's a force couple. So resultant will be 0. Therefore, there is no line of action. Is it clear, Hirosh? Yeah, the second one had a line of action because it has a different magnitude, no? So this is, for example, 30 Newton, and this is 10 Newton. Then the resultant will be in the direction of the larger force, and it is outside that. Okay, and then you can measure this distance and all. Okay. Okay then, guys. Good night. See you. Take care.